Assalamu alaikum. Okay, so let's start the lecture today. So in the last lecture, we discussed the assignment as well, and we also discussed something related to the database design basically, and completed 2.0. So in this lecture today, we are going to see some relationship types in database design, some join types and types of key. Whenever we are designing the database, and you're using a database management system using any language like SQL or NoSQL. So in that, we have to see the relationship types because when we are making the entities, when we are making different tables, the join types and types of keys like primary key, foreign key, which we will see later, they are used extensively. So first of all, what is the database relationships? Database relationships define how data in different tables are connected. Right, in the last lecture, I added some images in which there were some relationships, one to n, many to n, and one to many. So those are basically relationships. They show how different tables are connected with each other. And these relationships, these are essential for organizing data and reducing redundancy. That means that data does not need to be repeated every time. So they reduce redundancy and ensure integrity in RDBMS or relational databases. And there are three main types of database relationships, which are one-to-one, one-to-many, and many-to-many. And they're implemented using primary keys and foreign keys. So why is relationships matter? Like, what is the importance of the database relationships? They prevents duplicating data across multiple tables. Okay. So to reduce data redundancy and duplicated data across all of the tables, we need to make sure like whatever relationship we are using, it has only data only one time, like the data is not duplicate across all of the tables, and ensure accuracy by forcing links between records means rows, like how we have rows and columns, such as preventing an order from being created for a non-existent customer. So if a customer does not exist, then how can we create order for that customer? So this is how we ensure accuracy. Then enhances performance for data retrieval and database organization. So these are basically how like three types of relationships, what they look like. School to head teacher, like one-to-one means basically there will be only one school, and then there will be only one head teacher. Obviously, a school has only one principal, one headmistress, right? Then for one-to-many, we can have one school has many teachers. So this is how we show one-to-many relationships. One school has many teachers or one class has many students, then many to many. So many pupils or many students take many lessons, like they take multiple subjects. So this is a case of many to many. Now, what is a relationship? Relationship in a DBMS exists when a variable has a connection with the property stored in different variables, different tables. Okay, like how, for example, in this case, one-to-one relation, we have the school table and then we have the head teacher table. So in the school table, the attributes for the school could be school name, school address, school number, etc. And for head teacher, we can have ID, name, address, and qualification, for example. Then such relationships help the organization of entities intertwined with each other, ultimately enabling efficient data processing. Like that means that all of the tables, if there are more than two tables, three, five, how many tables, all of these are connected because of the relationships. They are exhibited usually via keys in a table, the primary keys or foreign keys usually, which is either columns or fields that specify a distinctive arrangement for each record. So for example, one can think of the university database. So in the case of university database, you can say one university has many students. And then in the case of university, in the last lecture, we saw that the university has departments and administration. So one department can have many faculties, basically like that. So students, courses, and instructors variably they become tables. The relationship between the two tables is that courses indicate which course the student can enroll in, right? In the case of like universities. So this is how one-to-one relationship looks like. This person has two IDs. First one is the ID, which will be the primary ID, and then this again the second ID, birth certificate ID, which is linked with this birth certificate table. This birth certificate table has this primary ID called ID, and when this is linked to this person table, it will be acting as a foreign key in this person table. We'll see this in the coming slides. So this is a one-to-one relationship. That means that one person can only have one birth certificate ID. That means that your CNIC number is only linked to you, and no other person can have the same CNIC as you. They can have the same name as you, but they cannot have the same ID, same CNIC. So a one-to-one relationship in database design occurs when each record in table A or table number one is associated with exactly one record in table B, and vice versa. Like this, one record in this person table birth certificate ID is linked to this record ID in birth certificate table, and similarly, this ID record is related with the birth certificate ID. So it's a one-to-one relationship. And it is a bidirectional. That means it works in both directions. Unique connection used to structure data. You will be using mostly the primary key for that purpose, which is a unique ID basically. Enhance security or manage performance. So its key characteristics are, first one is bidirectional uniqueness. So record A1 connects only to B1. That means the record A1 is in the table A and the record B1 is in the table B. So record A1 connects only to B1 and B1 connects only to A1. This is how it works. Then implementation, typically enforced by placing the primary key of table A as a unique foreign key in table B. In this example, this the same is happening, that in this we have two tables, person and birth certificate. So in the case of birth certificate table, there is this primary key ID. This is acting as a foreign key in this person table. That means that both of these tables are being related through the primary and foreign keys, and they are having a one-to-one relationship. Then next key characteristic is optionality. So while it can be strictly mandatory one-to-one, it is often implemented as one or 0 to 1, meaning a record in table A might not have a corresponding record in table B. So it's optional that there can be a one-to-one relationship. Like it's like strictly mandatory, there has to be a one-to-one, but in some cases, sometimes a record in table A might not have any corresponding record in the other table. So for example, user and user profile. So a user table holds credentials while a user profile holds table holds bio or picture data. So both of these tables will be having a one-to-one relationship. Then person and passport. A person can have only one passport. A person has one passport. Like for one country, he can only have one passport, right? And for another country, he can have a different passport. And a passport belongs to one person. Then employee and company car. So an employee is assigned exactly one car by the company, right? So this is a one-to-one relationship. Then what are the implications of one-to-one relationships? It has several design and operational implications. First one is data security and privacy. So that means sensitive data can be isolated in a separate table. For example, employee and employee salary, allowing restricted access to the sensitive table without affecting the main record access. Second one is the performance optimization. So large, infrequently accessed columns can be moved to a secondary table. This reduces table size for common queries and it can improve performance as well. Third implication is handling optionality sparseness. So if only 10% of employees have a specific large set of optional data, separating that into a one-to-one table prevents 90% of the table rows from containing null values. That means it can handle optionality. And next is database normalization. So this helps in breaking down white tables to meet normalization rules. We'll see what database normalization is. And next is complexity in query. So one-to-one relationships require SQL join. It's a type of join basically where we join two tables based on the rows on the records. And so this operations to retrieve combined data like from both of the tables, which can make queries slightly more complex compared to single table design. Meaning that if you were to retrieve using a query, if you were to retrieve data from a single table, you would be able to do it easily. But in the case of like multiple tables, if you were to retrieve data, you would have to use any one of the join type in SQL language. So that can have very complex queries and it can be complex to handle as well. Next, last one is a data integrity constraints. To enforce this one-to-one relationship, the foreign key column must be declared as unique, okay, to prevent a second record from pointing to the same primary entity. So these are the implications of one-to-one relationship. Next is one-to-many relationship. One-to-many relationship, that means that one person, for example, can has many some things like one order, for example, in this case, one order has many items, right? So you go to a restaurant, for example, and you order something and you order like 5 things. So your order is like your order ID is one, Okay, and the items that you have ordered, they are how many? 5 or 6. So one to many relationship like this. So one to many relationship is basically in is a fundamental type of data association in relational database design, object-oriented programming, and conceptual modeling. Like this one-to-many relationship is used in all of these things. It occurs when a single record in one entity, the one or the parent side, is associated with 0, 1, or multiple records. So we can have 1 to 0 or 1 to 1 or 1 to many records in another entity, in thus another child, in another table, the many child side, while each record on the many side is associated with only one record on the one side. That means that in this example, you can see one order has many items, okay? But if you associate many items with this order, you will be saying many orders to one items, like many to one, not many to many orders, many items to only one order. That is how you will say it. Then next we have the key characteristics. So it's directional, single valued in one direction. That means one to many, right? Like one order has many items, but multi-valued in the other. So it is like it has two directions. Okay. So many items are linked to one order like this. Then it has a parent-child structure. So the one side acts as a parent, basically like how, for example, one parent has many children. Okay, one parent has many children, and then many children have one parent. Like it's a one to many relationship. Then next is implementation. So it is implemented by placing the primary key of the one side table into the many side table as a foreign key. Like in this case, we have made the primary key of the order table, which is ID, act as a foreign key in the item table as order underscore ID. This order underscore ID is acting as a foreign key in the item table. Then what are the examples? So first example is customer order. So a customer, that is one customer, can place multiple orders, but an order, like it's many, belongs to only one customer. In the case of departments and employees, a department can have many employees. Our department has many employees, but each employee works in only one department. No two employees, like no employee will work in two departments at a time. And what are its implications? So, reduced redundancy. By separating data into tables, one-to-many relationships prevent the need to repeat parent information. Right? For example, customer details for every child or record, for example, each order. Then referential integrity. That means the foreign key constraint in the many table ensures that a child cannot exist without a valid parent. For example, no orphan daughters. That means that in the case of like the foreign key constraint basically makes sure that in the many table, like in this case of example, the items table, we can have basically like this is a child, it cannot exist without a valid parent. It needs to have a valid only one parent. And then about the join operations, to retrieve data from both sides, SQL join operations inner or outer are used. And next is indexing. So the foreign key on the many side should be indexed to ensure fast query performance, especially as data volume increases, right? And optional, a customer can exist without any orders. That is, a customer can go to a restaurant or a cafe and he might not order something. So it could be a zero to many like relationship. And then mandatory. Mandatory means that it's must to have like a one to many. So an order must have an associated customer. In this case, this is how it will work. Then what about scalability? This structure allows the database to grow efficiently because new child records can be added to the many side without changing the structure of the one side table. That is, in the case of one order and many items, you can have many new child records, many new table records added into the many side, while there will be only one order table side. Confusing one to many with a many to many. So misinterpreting a many to many relationship as one to many can result in severe data redundancy or improper business logic. This can happen when you are implementing the many to many relationship. So next is this one, the many to many relationship. Basically, this is how is this working? Like many, for example, many students. Okay, many students can have many courses, and then how they are basically linked. They are linked using a table that you have made, which is named as student underscore course, in which you will basically use the primary keys of both the tables, student ID and course ID, to link both of these tables. So a many-to-many relationship is a database connection where one record in table A, so where one record in table A links to multiple records in table B, like how many students can have many courses. In the case of university, for example, when a student enrolls in a semester, many students have like six, someone has six courses, someone has seven courses, like that. So such a students taking many courses and courses having many students, and in relational databases this is implemented using a third junction table. Like in this case we have made a third junction table to connect both of these tables primary keys, or it can be called, you can call it as linking or associative table, basically that connects the two primary tables via their foreign keys, effectively breaking the uh, many to many. You can write it as either m to n, m ratio n, or you can also write it as m ratio n, but it's most effective if you use the m ratio n because this is most commonly used. Okay, so effectively breaking the many to many link into two one to many relationships. Okay, table A to junction and then junction to table B. Like in this case, this joint table, this is the junction. It is linking with the student table as well and with the course table as well. So this is basically done to avoid data redundancy and complexity. And what are the key characteristics for the many-to-many relationship? First one is the cardinality. Each instance in one entity relates to zero, one or many instances in the other, and vice versa, like many-to-many relationships. And then implementation requires a join, junction, or linking table. Okay, we need to make a linking or join or junction table for this purpose if you want to implement many-to-many relationships. And next is data integrity. So it prevents data duplication. And that means it does normalization. Okay. And last one is flexibility. So it allows complex associations like customers buying multiple products, for example, in the case of like online shopping, or users belonging to multiple groups. Okay. Next is how it works. Like in the case of, for example, students and courses table, this one above, how this works. So the first one is the entities. That means the tables. The tables which you will make in the DBMS or in the database, they are called as entities. And there are only two entities. Okay, first one is the students. In that students table, you can have the student attribute. For example, you can have student ID, name, etc, etc, all of that. Then in the courses table you can have a course ID. So in the case of, let's say in the case of someone is studying at university, they will be taking some course, for example this course like data and database systems. So this course has its own ID which separates it from the other course. So you can have course ID, title, and something else as an attribute in the table. What is the problem? You can't directly link a student to multiple courses. Okay, you can't directly link one student to multiple courses and a course to multiple students in a single table without repeating data. Okay, so what is the solution? The solution is the junction table. Create a student courses table or student underscore course table, like in this case. Okay, and the next step is it contains basically foreign keys from both students and courses. The student ID and course ID are basically the primary keys. Okay, these are the primary keys of the tables, but in the junction table they will act as a foreign key. Okay, so each row in student courses represents one student taking one specific course, so that data is not repeated multiple times. And what will be the result? A student's ID appears multiple times in student courses for each course they take, which is a student to junction, one to many relationship, right? And then a course's ID appears multiple times for each student enrolled, which is course to junction, that is one to many relationship. So this is how the many to many relationship works. Next is the implications of man-to-man relationship. So first one is the necessity of junction tables. That means that without a junction table, it is hard to implement many-to-many relationship. So this table is used to link two main entities, right? Transforming one n to m relationship. This is a also an many-to-many, right? And n ratio m. Okay, relationship into two one-to-many relationships. That means that one student, like student table is linked to this junction table student underscore course. So one student will be like one student has many courses. Okay, and then the course table is also linked to the student underscore course table, so many courses are being taken by this one student. So in this way data will not be repeated all of the time. Then data redundancy and integrity. So directly relating two tables often causes duplicate values. That is why we use a junction table, such as listing a professor multiple times for every subject they teach. This can cause a lot of issue, and this can cause obviously duplicate values. So that is why we use the junction table to avoid that. And lastly, performance and querying. So many to many relationships can be complex, right? Potentially requiring more computational resources and making queries slower if not implemented correctly. Whenever we are basically, if we just make this table like this, okay, for any many to many relationship, we can understand like what is happening because of this junction table. But if we were to write a query using structured query language or SQL in any database management system, that query can take some time to load. Okay, that means it can have an effect on the performance if it is not implemented correctly. So this was about the different relationship types and their implications. Next is the join types. There are four join types: left, right, inner join, and full join. Okay. So SQL joins are categorized into different types based on how rows from two tables. Okay, what we are going to do in joins, if we use joins, we are going to take rows from two tables and match them, like combine them. Okay, so first one is the inner join. The inner join in SQL returns only the rows where there is a matching value on both tables. So suppose there are two tables, student and course, or any two tables, let's take, and each of those tables has a similar the same record, okay, or the same row. So we can use inner join to basically return only those rows where there is a matching value in both of the tables. So it combines records. Records are also called as rows in database. Okay, so it's the same thing. It combines records or rows based on a related column and excludes non-matching rows. So we will only write those rows. We will only take those rows which are the same, which have the same matching value in both of the tables, and the rest they will be ignored. So we can also write join instead of inner join. It is the same thing, right? So this is how the query in SQL looks like. Select table one dot column one. Okay, then table one dot column two, table two dot column one, etc., from this table one. And then we will use this inner join keyword, table two on table one dot matching column. That basically it's a query to make you understand how inner join works in structured query language. Okay. So this is an example of inner join. Consider the two tables, student and student course, okay, which share a common column, roll number. Okay. So using SQL joins, we can combine data from these tables based on their relationship, right? If they have a one-to-many or many-to-many relationship, so based on those, on that relationship, we can combine the data which have the same, basically, the records or the rows, allowing us to retrieve meaningful information like student details along with their enrolled courses, right? Then let's look at the example of inner join clause and understand its working. This query will show the names and age of students enrolled in different courses. So it's basically a query written in SQL language, okay, where you have the select student course ID, and then student dot name, student dot age. Basically, you are selecting all of these columns, okay, from the student table, from student. Inner join, then you are joining using inner join student course, okay, on student roll number and equals student course dot roll number. So this is your output basically, in which you will have the course ID and the name of the student and their age basically. Okay, so this is how inner join looks like. It's kind of like a Venn diagram, but it's more like basically what is common. Which rows are the common, which records are the common in both of the tables. You will only take them. Then what about the left join? So left join returns all rows from the left table, from the name, okay, along with matching rows from the right table. What does a left join do? Left join returns all rows from the left table, right? And only the matching rows from the right table. If there is no match, null values are returned for columns from the right table. And left join is also known as left outer join. Okay. So this is a query. Basically, this is how it works. And then in this case of example, we can see the left join retrieves all rows from the student table. Okay, this is the output, and the matching rows from the student course table based on the roll number column. So this is how it looks like in the if you visualize it. And then what about the right join? Right join basically returns all the rows of the table on the right side of the join. Okay, and matching rows for the table on the left side of the join, the basically the opposite of the left join. Okay, and it is very similar to left join for the rows for which there is no matching row on the left side. Like if the records don't match, the result set will contain null values. Like how here we see Olivia Brown. Olivia Brown does not have any course ID, so there will be a null value, no value for that. And then for Ava Davis as well. And right join is also known as right outer join, and this is its query. Basically, this is how it works. It looks like. Okay, so in this example, the right join retrieves all rows from the student course table. Okay, and the matching rows from the student table based on the roll number column. So you can see there is for this course ID 6, there is no student. That means it's a null value. So, and this is how it looks like. Last join type is the full join. Okay, so full join creates the result set by combining results of both left join and right join. That is why its name is full join. Combine both the results of left and right join. The result set will contain all the rows from both tables. Okay, for the rows for which there is no matching, there will be null values. And here in this example is you can see the output. For every student, there's a course ID, but for these two students, Olivia Brown and Ava Davis, we do not have any course ID. And for this course ID 6, there is a null value. That means there is no student here. Okay, so this is how full join looks like. Combine all of the data from both the left join and the right join. Next, we have database keys. So database keys are basically keys that I have been talking about primary key and foreign key. Okay, so there are these basically keys, but mostly we use are the primary key, super key, candidate key, and foreign key. All of these. So keys are what are keys? Keys are fundamental elements of the relational database model. And what is a relational database model? It's a basically contains rows and columns, right? So they ensure uniqueness, right? Data integrity and efficient data access. They uniquely identify each row in a table. That means each record has a unique identification. Okay. Like your CNIC, for example. So they prevent data duplication and maintain consistency, and they create relationships between different tables. So what is their importance, or what is the importance of keys in database management system? First one is the uniqueness, because they ensure that each record or each row in a table is unique and can be identified distinctly. Okay, no two rows should have the same ID, because then we would be unable to identify the data. The next importance is data integrity. So keys prevent data duplication and maintain the consistency of the data, like how in above types of relationships we saw foreign keys being used. So foreign keys sometimes they prevent data duplication. That's why we use them. Then next we have the efficient data retrieval. So keys help in creating relationships between tables like one-to-one, one-to-many, many-to-many, allowing faster queries and better data organization. And what about establishing relationships? So foreign keys link tables together. We saw this example above, right? Facilitating relationships between different entities in the database, allowing for structured interconnected data. And next is data validation. So keys are used to ensure that only valid data is entered into the database. Only valid data, unique data, and data that is not duplicate, which helps in maintaining the overall quality of the information. So next is the types of keys basically in the relational model. So first one is the super key. Super keys are basically the set of one or more attributes. Attributes means columns, like the ID, name, address, all of these are columns. Okay, the set of one or more attributes that can uniquely identify a tuple. Tuple is called a record. Record is also known as row. They are very similar names, but sometimes they are used like this to confuse. Okay, so tuple, record, and row is the same thing, and attributes and columns is the same thing. Okay, so the set of one or more attributes that can uniquely identify a record or a tuple or a row is known as super key. So it may include extra attributes or extra columns that aren't important for uniqueness, but still uniquely identify the row. For example, in the case of student table, you have a student ID, you have student name, you have student email, maybe student contact number. Now you can use student ID, student name, student contact number, and student email to uniquely identify any student. Okay. And even if both of the students have the same name, they will have different student IDs, they will have different contacts, and they will have different emails. So that will be a set of super key. So super key is a group of single or multiple keys, okay, that uniquely identifies rows in a table. The primary key is also a subset of super key, okay. So it supports null values in rows. That means you can have a null value in the row. A super key can contain extra attributes that aren't necessary for uniqueness, like in this case, student name, for example, or student. Okay, in this case, consider as a student table. We have the student number or the student ID, name, address, and phone. So all of these attributes or columns can we can use them as super keys. Next is the candidate key. Candidate key is the minimal set of attributes that can uniquely identify a tuple or a record is known as candidate key. So for example, student number or student ID, it's a candidate key. It's also a primary key, but it can also act as a candidate key. It is also a candidate key basically. Okay? It contains no extra attributes. Okay, it doesn't contain any extra attributes. It is a super key, right? As I said, primary key, candidate key, these are subsets of super keys. It is a super key with no repeated data and is called a candidate key. The minimal set of attributes that can uniquely identify a record or a tuple, and a candidate key must contain unique values. So how in this case you can see student number, student ID has unique values for each student. Okay, so it ensures that no two rows have the same value in the candidate keys columns. And every table must have at least a single candidate key. Okay, a table can have multiple candidate keys, but only one primary key. Remember, in the case of database management system, whenever you're making a database, there will be only one primary key. You can have multiple candidate keys or super keys or alternate keys, but there will be only one primary key for that. So in this student table, the student number column, this is your primary key. Okay, it can be a candidate key because it uniquely identifies each of the student. And then as for this student course table, you can have the course number and teacher number column, and you can have the student number column as well to uniquely identify the records. They will be your candidate key example. Then primary key is the unique value, the unique ID basically, which is chosen from the set of candidate keys, okay, to uniquely identify each record in a table. For example, student number, okay, in this case, and in the case of teacher table, teacher number, teacher ID, for example. So it uniquely identifies every tuple, every row, and does not allow duplicate values. You cannot have same ID for both of the rows. That will throw an error if you try to make one. And it cannot be null. Okay, it cannot be zero. It will always start from one in this case. Okay, as each record must have a valid identifier. And like in the case of your CNIC, for example, okay, your ID, national or your passport number, for example, every person whoever makes a passport, like whoever has a passport, has a valid passport number, which is different for everyone, right? No two people have the same record for that, and it may be single column or composite. Made of multiple columns. So databases often organize data using the primary key to allow faster access and searching. So in this case, you can see the student number table is the primary key. Okay. So what about the alternate key? Alternate key is any candidate key in a table that is not chosen as a primary key. So for example, in this case, you can choose phone. Okay. You can choose the phone column to act as your alternate key instead of the student number, which is your primary key. Okay. So in other words, all the keys that are not selected as the primary key, okay, they are considered alternate keys because the word alternate literally means alternate, right? And alternate key is also referred to as a secondary key. Its second name is secondary key because it can uniquely identify records in a table just like the primary key. So here, if you take this phone column, this phone key as and make it your alternate key, so no two students can have the same phone number unless they are brothers and sisters. Okay, so this can be your alternate key, and alternate key can consist of one or more columns or fields that can uniquely identify a record, but it is not the primary key. Okay, it is your candidate key. It is your alternate key. Basically, the super key is a whole set. Okay, and in that set you have the candidate key, you have the alternate key, and you have the primary key. And here in this example, you can see, look at the student ID. This is acting as a primary key. Then what is can be the alternate key? Roll number, first name, last name, email, phone number, etc. All of these are your alternate keys. And what about the candidate key? All of these columns, these are your candidate keys. Okay. So primary key and alternate key are subset of candidate key, and then candidate key is a subset of super key. And what about foreign keys? So foreign key is an attribute in one table. What is an attribute? It's a column. Okay, it's a column in one table that refers to the primary key in another table. Okay, and they act as a cross reference between the tables. It helps connect two or more tables, like in the case of relationships above we saw. And the junction table, we use the foreign keys basically. Okay, the table that contains the foreign key is called a referencing table because it is referencing the ID from another table, and the table that is referenced, okay, is called the reference table. Okay, and this table, the student underscore course table, this is your basically table in which you have the foreign key. Okay, so this is table is a foreign key that refers to the student underscore number. Okay, primary key of the student table, and then for the teacher underscore number, it is acting as a foreign key from the teacher table, and similar for the course underscore number for the from the course table. Okay, so these are basically acting as foreign keys in the student underscore course table basically. Next, we have the composite key. So composite key, sometimes a single column is not enough to uniquely identify all records in a table. So a combination of multiple attributes or multiple columns is used. So an optimal set of such attributes is chosen to ensure that every row is uniquely identifiable. Okay. So it acts as a primary key. The composite key acts as a primary key, but if there is no primary key in a table, okay, if there is no primary key, you can use a composite key as a primary key. So two or more attributes are used together to make a composite key to uniquely identify a record basically. So different combinations of attributes may give different accuracy in terms of identifying the rows uniquely. So this is how it looks like. Okay, in the case of composite key, you could basically be using the alternate key, okay, from one table, and then this foreign key from another table. From this is table one and table two. Okay, basically using multiple keys, two or more keys, if there is no primary key, to uniquely identify records in a table. Okay, as you can see, primary key, candidate key, alternate key, these are subsets of super keys. Okay, so this was about the different relationship types, join types, and types of key. And that is it for our lecture today. Okay, so that's it for our lecture today. I'll see you in the next lecture, inshallah. Okay, Allah Hafiz.